Hello, today we are going to present you a project related for analysis of student activity on e-learning courses based on openedx platform logs. Online electronic educational learning platforms are very popular nowadays. One of the biggest and widely used platform is openedx. This is open source software platform which provides off-the-shelf tools for educational services. One of the important features of the platform is that it generates student and teachers activity log files. But the disadvantage of the platform is that it doesn't provide any data analysis tools for monitoring educational progress and success. The most popular educational platform in our region is Open Education. The problem of the Open Education platform, which is a particular implementation and customization of OpenEDX platform, is that the teachers conducting courses on this platform are missing the tools for analysis the educational process, which leads to missing control on the educational process and decreasing its efficiency. From the other hand, the students who use the platform are also not able to monitor their academic performance. So it's very important and critical to provide teachers, course administrators, and students with educational analytic tools that helps them to make the educational process more efficient. Improving online educational platforms can make online learning at universities more friendly, easy, and happy for all the involved actors.
Our solution has the following steps. First one, make a research in structure and format of the OpenEDX platform logs. Second, formulate and create analytic tasks that can be applied to the logs. And the last one, implement a software solution that demonstrates the idea and all the possibilities that OpenEDX provides.
Our team consists of 4 people: faculty advisor, 1 front-end and 2 back-end developers. In our team, we prefer to use Scrum with a 1 week sprint. And every month we show the results to the customer. After that, we do the retrospective. So our risk is about sicknesses of the team member, leave of the team member, and some issues with product, such as task is not completed before deadline, or we cannot release product version on the time.
The following functional requirements were made for the end software solution. Firstly, the solution should be able to process logs of strictly specified format. Also, it should provide user with a list of available logs. All the logs are stored in the database. The solution should provide login page for user authentication on the platform. After running an analytic task, the solution should retrieve and provide user with the result of its work. These results may be represented as a text report or as a graphical diagram. And also users should be able to download this result in CSV format. Our solution also has the following non-functional requirements. Firstly, the system should prevent data loss during restarting of the system. What about analytic tasks? They should work fast and take no more than 1 minute to execute. The solution should be fast integrated into customers' company business processes with minimal costs for the company. Also, OpenEDX platform contains personal data about students and teachers, so the system should provide security of the data and prevent any data leaks. The system also should follow the GDPR regulation. Technical architecture of the solution consists of 3 main parts. The first one is UI service, which allows user to interact with the system, make requests and get results. The second part is ETL service, which provides data for the analysis. It receives log files from the openedx platform, transforms and prepares the data, and then loads it into the database. The third part is analytical service. It contains a set of analytical tasks implemented as scripts, which get data from database and then return the result in a file.
So our UI consists of the React, Redux, Bubble and Webpack. Our backend microservices consist of Java 8, Spring, in particular MVC and Spring Boot, and all the things build up with the Gradle. All our microservices communicate with each other using the REST paradigm. All logs are stored as JSON files, and to store these logs we choose a Postgres. So we use it as a non-SQL database, and for the reason that the Postgres contains enough functions for working with JSON and strings, and this helps us to write queries for working with database much more productively. And all the results we can store in XLX and CSV files.
Let's see a demo example.
Welcome to the demo. So our project is an independent project for analyzing logs that consist of the user actions from the educational project openedu.ru. So let's take a look at them. So this log contains many fields. The most important is event type and event. So event type shows what the user has done, and event shows in more detail what was done by the user. As we can see, the user clicked and the target URL was something like that. So based on these logs we can conduct a complex analytics. To store the logs we choose a Postgres. We use it as a non-SQL database for the reason that Postgres contains enough functions for working with JSON and strings, and this helps us to write queries for working with database much more productively. Let's look at the front side of our project. So our front side provides a simple interface for interacting with our project. To create it, we choose one of the most popular frameworks, the React.js. So let's look at the Logs tab. On the Logs tab, we can see all available logs on the server and all loaded logs on the database. We can clear our database and load one or several or all available logs on the. Let's look to the Analyzer tab. On this tab we can see all the available tasks for analytics. These tasks can be applied to the logs in the database. Naturally, tasks may depend on what needs to be analyzed, and we made a convenient architecture for adding tasks on the backside. So let's run some tasks which could show us user way on the course. Here we are. On this graph we can see the URL that the user visited on the course. This page URLs means week 1 lections, week 1 test, week 1 discussions, and week 2 lections. And we can see here a timeline, February 17th and so on. So let's look at these red dots. This is event, so we can see here the user opened 3 tabs at one time. I think he can study something. And the next session began at March 5. He just studying, like lection of the week 1. In the next day, March of 6, he began to study lections of the second week, and he opened these tabs again. And yeah, last session is March 13th. So what did it give us to us? So according to this graph, we can conclude that this user watched the lectures for 2 weeks only, which by the way are from 18 to 16. After that, he decided not to continue studying, visiting only about 4 times this course. But why? We can write him a letter and find his opinion. Perhaps he didn't like the teacher or the material was poorly presented. As a CI/CD, we use a Heroku CI. It allows us to use all the features of the CI/CD, such as running tests after all commits or host our application and so on. And important thing here, we want to use an automatic documentation, and we use a Swagger for this purpose. Our backend uses a Spring MVC, and all this together turns out an excellent documentation that helps us to notify our developers about new endpoints immediately. Thank you very much for watching us. So our future plans is produce an ability to get log files directly from a platform. So we want to ask the customer to make a special API for downloading logs directly from their site. And we want to run several projects with students and teachers, so we want to let teachers take advantage of the project. We want to finalize integration of the web application with server side, so we need to finish a lot on both front end and back end side. And we want to reduce time of the processing the analytics task.
Thank you very much for your attention.